In this section, we will go further into the pure Agile software development topics and we'll start familiarizing with hypothesis-driven development and experimentation, enabling us to manage our product end-to-end. We will define the principles for establishing the valid two-way dialogue between the business and the customer. This dialogue is fundamental in scenarios where our Agile software development is enabling and driving innovation. We will start from defining the business hypothesis and the methodology for experimenting and assessing their validity. We will then look at the feedback process and what practices we need to implement for listening to the spoken and unspoken customer feedback. Now we move on to the first video of this section that will walk us through how to formulate business hypotheses and how to experiment them. Reviewing this video, we will become familiar with business hypothesis and the A/B test, also known as split test. In this video, we are going to take a look at the criticality of testing the validity of user stories, how hypotheses are formulated and how they relate to features and user stories, the overall evaluation criterion as mean to objectively assess validity of hypotheses. We will finally look at how to design experiments based on A/B test. In the previous section of this course, we introduced the weighted shortest job first to compute the priority of user stories and/or feature. Through the exercise we did in the previous section, we came to the conclusion that in the Technis product, the user story, in order to have a fresh view of my service, me as service owner, I want to receive a daily recap each morning, is indeed our main priority, and we are expecting a fair benefit out of it. So the tale seems already told. We implement the user story at the done stage. We deploy to the production environment. The service manager, our customer or final user, starts to use it. Hence, the business has fully avoided the cost of delay and gained all of the benefits. Let's take a few steps back. The factors we used in computing the cost of delay of the user stories are based on educated assumptions we elaborated thanks to interviews with the service managers and thanks to the experience of Amelia, our product owner. While we all believe that those are critical actions for de-risking the misalignment between expectations and outcome, there is still a level of uncertainty whether our product increment will deliver the computed outcome and/or will drive the expected behavior in the customer. The more innovative our user story is in terms of introducing something new as behavior, technology, opportunity, etc., the higher is the level of uncertainty whether our product increment will deliver the computed outcome or will drive the expected behavior in the customer. Given scenarios where our customer population is highly distributed, vast and complex, we then risk that our assumption is far off from reality. In this screen, we collected some of the comments from organizations certainly smarter and more innovative than us. We are impressed with the low rate of changes that lead to the expected business benefits. When Google is stating that about only 10% of controlled experiments were leading to business changes, we do think there is enough argument for us to take in consideration testing and experimentation. Every one of us has good, better, excellent ideas, but this is not what makes us innovative. The lesson we learn from the statements in this screen is that Google and all the other successful brands is innovative not because it has plenty of ideas. Google is innovative because it has a solid and fast method of assessing the value creation of the hypothesis carried out at Google. What are the tools and the framework we can use for restructuring our user stories and hypothesis to validate? Barry O'Reilly, author of How to Implement Hypothesis-Driven Development, provides a very valid and straightforward framework to document hypothesis-driven development, or HDD, user stories based on the business hypothesis template. We believe this capability, what functionality we will develop to test our hypothesis, will result in this outcome, what is the expected outcome of our experiment. We will have confidence to proceed when we see a measurable sign, what signals will indicate that the capability we have built is effective, what key metrics, qualitative or quantitative, we will measure to provide evidence that our experiment has succeeded and give us enough confidence to move to the next stage. The framework we used for user stories so far, in order to, me as, I want, is enhanced by the hypothesis-driven development. While keeping the same strong focus on capability and outcome, HDD does enrich the context with a focus on measurement. We are concluding that the framework we used so far to define user stories is wrong or incomplete? No, this is not the conclusion we want to endorse. The framework we used so far for defining user stories is very valid in scenarios where the level of uncertainty, wherever our product increment will be delivered, the computed outcome and/or will drive the expected behavior in the customer is low or manageable. For scenarios where the innovative aspect is critical, HDD is the framework we recommend to adopt. With HDD, we introduced the importance of assessing measurable signals that drive the decision where our hypothesis is confirmed or must be adjusted, if not dropped. The speed on how we obtain valid measurable signal and how we discard noise is crucial. We cannot wait to measure the effective saving that our user story might deliver in 1 year's time. We need to define the surrogate measures that, in the short term, days, 1-2 weeks, can confirm our hypothesis and provide all the relevant insight to decide on what direction to move ahead. We hence define the Overall Evaluation Criterion, OEC, as the single quality indicator combing multiple criteria of evaluation for the business hypothesis. The key factor for the OEC is to predict long-term goals based on the metric values measured in the short term. What we can learn in the short term that gives us the right confidence we will gain the expected outcome in the long term? The answer very much depends on the hypothesis we are taking into consideration. For example, let's work on one OEC for the user story. In order to have a fresh view of my service, me as service owner, I want to receive a daily recap each morning. Our hypothesis is the dashboard holding the key 7 scorecards recapping the service performance will be the single stop shop for the service manager every morning. Even if not explicitly quantified, we are expecting the service manager to gain from the dashboard the view on service performance and to have the right data to set the priorities for the day. The service manager is going to be more efficient because she has not to pull information from different sources, but they are pushed to her in an aggregated view. So what is the metrics that we can use in the short term to assess the measurable signal? We do think that we could consider qualitative and quantitative metrics in defining our OEC. For instance, let's review together this template for experimenting the validity of user stories, taking a sample population of 5 service managers. For 10 consecutive days, we will measure the time, if any, spent by the 5 service managers on the dashboard. Those data will drive the 3 quantitative metrics. Recency, when lastly the service manager spent a minimal time on the dashboard to scan the 7 scorecards. The more recent, the better. Frequency, how many times the service manager went on the dashboard, the minimal time to scan the 7 scorecards. The more frequent, the better. Duration, how many minutes the service manager spent on the dashboard. 0, no time. 1, she bounded, she spent no effective time. 2, she spent the minimal time to scan the 7 scorecards. 3, she spent between 2 and 3 minutes. 5, she spent between 3 and 5 minutes. 8, she spent more than 5 minutes. For duration, we are assuming the more time she spends on the dashboard, the better. We leave aside for now concerns as she might spend considerable time on the dashboard just because the dashboard is not intuitive or user-friendly. In addition, the 6th day of the experiment, we run a quick survey where we ask one single question. Did you find in this dashboard the information you need to drive efficiency in your service today? Score: -1, no. 0, no answer. 1, partially. 3, yes. We finally compute our OEC as A** recency plus B** frequency plus C** duration AVG plus D** survey score, where A, B, C and D are coefficients to weight and adjust the metric's priorities. The values reported in this Excel makes all the factors of the OEC equivalent. In this second Excel, we already reported the data observed in the experiment. We could define the boundaries as, for an average score lower than 0.5, the max value, which is 50, the hypothesis is discarded. For an average score higher than 0.6, the max value of the hypothesis is verified, as in our example. For an average score between the two, we might want to find out what could be adjusted. The experiment we just demonstrated helped to define the OEC and take a decision wherever our hypothesis of increasing the efficiency of the service manager has solid basis or not. For example, this experiment can be done before we decide to roll out the dashboard capability to other service managers, or we put more effort on getting the dashboard right, full data, additional columns, optimized user experience, etc. Before any additional investment, we want to be sure this is driving the expected benefit. Another case could be when we already assessed the overall validity of our user story and now we want to enhance the service manager user experience. For example, we could debate if the first scorecard showed in the dashboard should be the number of active service requests or the average age of the active service requests. Looking outside the Technis product, another common context for experiment is in digital marketing. Very often we need to decide which color or wording or position in the page to use for highlighting new promotion and new e-commerce solution. The experiment strategy to take in these scenarios is the A/B test or split test. A/B testing certainly deserves a course on its own, so we are not pretending here to cover all the aspects. We want only to familiarize with the key items to consider when planning A/B test. Control and treatment, A/B test. A/B evaluates the factor on two levels. Control, the A, treatment, the B. As per common practice, we call the control the existing default version and the treatment is the hypothesis to test. We divide our customers in two groups and we direct one group to the control and the other group to the treatment version. We measure their behavior and then we decide if the treatment is fulfilling the hypothesis, for example, increasing the engagement of the customer. Null hypothesis. The null hypothesis or null test is when we perform the A/A test, where control and treatment are the same. This is a technique used to ensure that our split of the customer is not altered by other factors. In theory, we should observe that the two groups have a very similar, if not identical, behavior when facing the same experience. Sample size, variance reduction, and confidence intervals. In terms of sample size, there are two aspects we need to define: the number of users to engage in the experiment and the length of the experiment. Best practices used are the traditional statistic for what concerns the sample population, and in terms of length, we might want to consider 1 week to evaluate all the potential cycle. The more we increase the sample size, the more we increase the power quality of the experiment. On the other end, increasing the sample size increases the cost of the experiment. The variance reductions are techniques for improving the power of the experiment without increasing the sample size. For example, we focus on customer segmentation or pre-analyzed customer data. Another mitigation for keeping low the cost of the experiment while increasing its power is considering relevant confidence intervals. OEC definition. Same as discussed earlier, either in A/B testing is crucial to identify the OEC. We do need to project in terms of long term, the metrics measured in short term. Randomization unit and analysis unit. The randomization unit is the factor we are tracking. We often use the visitor, the customer of our e-commerce solution, the service manager, and the Technis product. That said, the user is likely defined by a cookie. Hence, it is more appropriate to consider the cookie as the randomization unit. The analysis unit is the metric we are tracking during our experiment. In the Technis sample, our analysis unit was the duration of the visit for the given service manager to the dashboard. For an e-commerce solution, the analysis unit could be the revenue per transaction or the basket size. Decision-making and diagnostics. A common approach to deciding if the treatment is better than the control is the usual hypothesis testing based on normal distribution. This is the approach we took in the previous OEC exercise. Our A was no dashboard and our B was yes dashboard. It is also very important to instrument our experiment with a set of diagnostics that could help in controlling the progress of the experiment itself. This could provide alerts, highlights, in case of spikes or relevant variances. Diagnostics could bring an extensive amount of data points that facilitate automation and use of big data techniques in complex experiments. In this video, we extended the concepts of Agile software development, defining the hypothesis-driven development as the natural extension of Agile when the rate of innovation, as in the digital world, is very high. We introduced the ability to assess business hypothesis, defining the Overall Evaluation Criterion and A/B testing. We computed the OEC to validate the success of one of the main user stories for the Technis product. For the A/B testing, we highlighted all the key components to consider when designing our tests.